Medieval cities didn't sprawl. They went up, they grew upward, into these dense forests of timber and stone. This was long before steel, long before elevators. That vertical ambition, it wasn't magic, it was infrastructure, a set of systems, hidden systems, brilliant ones. They let these communities defy gravity. They let them thrive in this astonishing density. They managed clean water, but without pumps. They built fireplaces, and those fireplaces made skyscrapers possible. There was a legal right, a right to sunlight, and that right shaped entire streets. It shaped them. This forgotten ingenuity, it's from the past, but what could it solve? What could it solve for a modern city today? A city wall was a promise of safety. It was also a declaration of limits. Inside, you had order, community, law. Outside was everything else. For a long time, that made sense. But then a promise of safety can start to feel like a trap. The population grows, families get bigger. New people arrive looking for that protection, and the walls don't move. They're stone set deep in the earth, a fixed perimeter. There's no more land. Only the land inside that stone circle. Every new person, every shop, every need has to fit into a space that isn't getting larger. That's the catalyst. Absolute land scarcity, but it wasn't geography. It was human design for security. The wall created a pressure cooker. Think of a sealed terrarium. Everything inside has to coexist, to share, to grow in a balanced system. The city was that terrarium. Expansion was forbidden by law, by charter, or by the simple problem of defending a thinner wall. You couldn't just build outside the gates. That defeated the purpose, so the city turned inward. It looked upward. The value of land stopped being about width. It became about height. A narrow plot on a crowded street could be worth more than a field outside the wall. Because that plot had potential. It could hold a home and a workshop above it, and a storage loft above that, and living quarters for rent above that. The mindset shifted. The question was no longer how much land you owned. It was how much air above it you could claim. This pressure created an urban ingenuity. It forced a revolution in property rights, in architecture. The wall, that symbol of limitation, became the reason medieval cities learned to touch the sky. And if the wall defined the where, the next challenge was the how. How do you build these tall, heavy structures on crowded, uneven ground without everything collapsing? The answer isn't in the towers, it's in what's hidden beneath your feet. The ground under a medieval city was never solid. It was centuries of debris, old cellars, forgotten wells. To put a stone tower on that was a gamble. It would crack, it would collapse, so they took a different path. They built with wood, a system so ingenious it became the city's skeleton. The timber frame revolution, its principle was flexibility. Think of the human body, rigid bones but joints that allow movement. That's how it worked. Strength didn't come from solidity but from connections. They used joints, mortise and tenon, a wooden peg carved to fit a matching hole in another beam. Locked together not with nails but with wooden dowels, a joint that was firm but had give. It could flex. As the building settled into uneven ground, as seasons changed and wood expanded, these joints would shift. Just minutely, they'd grown and settle, redistributing stress through the whole frame. A stone wall might develop a fatal crack. The timber frame just sighed. Adjusted, and it was about speed too. The frames were often prefabricated. Master carpenters would craft the entire skeleton in a workshop, numbering each beam. Then it was transported, assembled like a puzzle. A multi-story structure could rise in days or weeks, not months. It decentralized construction. You didn't need a royal architect. A skilled local carpenter using these methods could orchestrate a city's growth, and the frame solved another problem: space. streets were narrow, property lines were fixed. The solution was to steal space from the air. Builders made upper floors jut out over the street, cantilevering from the main frame, more room inside without more land below. Walking down such a street, you moved through a canyon, buildings leaning in, their timber skeletons creating shelter below. That wooden framework was the first secret. A strong, forgiving, adaptable base. Everything else could rest on it. Walls, floors, the life of the vertical city. But a skeleton alone isn't a living body. Those timber frames did more than support a building. They allowed it to expand. In a place like York, walking a narrow lane, you sense it. The space tightens. The second story might extend over the street by a foot. The third story goes out even farther. Up at the top, the buildings from either side nearly meet. You're in a tunnel of wood and plaster. That's the jetty. It seems like a decorative touch, something from a tale, but it wasn't that. This was infrastructure. A structural answer to the constant pressure of the wall. The jetty was a claim. It took public air and made it private space. On a lot that couldn't get wider, the only way to grow was out, over the public way. Those few extra feet upstairs were incredibly valuable. Space for another room, a bigger workshop, storage for goods. It changed the economics of a narrow plot. But you can't just suspend a room in air. The secret was in the frame. The timber structure didn't end at the ground floor wall. Its main horizontal beams, the summer beams, were extended. They stuck out several feet past the wall below, like a branch growing from a tree trunk. Those beams created a solid shelf. Then, from their ends, vertical posts went down to meet the wall of the floor underneath. That created a strong, triangulated brace. Sometimes a special angled beam, a dragon beam, carried a jetty corner, sending the weight back into the building's core. It was a counterbalance system. The weight of the interior rooms and the back wall acted as an anchor that let the jetted front cantilever out safely. The building worked like a seesaw, balanced on its foundation. This wasn't only for space, it was for protection. Before proper gutters, a jetted upper floor acted as a huge eaves drip. Rainwater from the roof would fall clear of the lower wall. That wall was often made of weaker stuff like wattle and daub. It kept the building's structural heart drier. And in a crowded city, it shaped the social space. That overhang gave shelter to people walking below, a covered path in the rain. It also meant neighbors lived very close. Their windows almost faced each other across the street. Privacy was rare. Community was built by the architecture. The jetty pushed the city's skyline outward. It made those iconic leaning streets a physical sign of urban ingenuity. A limitation turned into an advantage, beam by beam. But all this wood reaching upward created its own danger. A single spark in one of these timber canyons could wipe out centuries in an hour. The vertical city's greatest strength was also its deepest flaw. Fire was the thing city planners feared most. A spark in those wooden streets could wipe out a whole district in a few hours. For the truly ambitious building, the kind meant to last for ages, wood wasn't enough. It didn't have that sense of permanence. It didn't carry the right weight, so they turned to stone. And that decision started a revolution in what you could even build. The Gothic breakthrough wasn't just aesthetics. It was a new rulebook for handling gravity. It came down to 3 innovations: the pointed arch, the ribbed vault, and the flying buttress. On their own, each one was clever. Combined, they became a system. Consider the main problem with a stone structure. It's the crush of its own mass. A classic rounded arch pushes that weight outward and down. To support it, you need massive walls with very few openings. A Gothic pointed arch works differently. It sends more of that force straight down, which means the supporting walls have less sideways pressure to contain. They can be thinner, but the real change happened up above with the ribbed vault. Imagine the stone ceiling of a large hall. Instead of a single heavy slab, the masons built a skeleton first. They set up these elegant stone ribs in the shape of pointed arches, crossing one another. That network of ribs created a framework. Then they filled the gaps between them with lighter stone panels. The ribs bore the load, directing it down to specific points like columns. The weight wasn't a uniform press across the entire wall anymore. It was now a set of concentrated loads, and that's what made the flying buttress possible. It looks like a stone arm extending from the building side. That arm intercepts the outward push from the roof vaults. It redirects that thrust down into a heavy pier set apart from the main wall. The wall itself was freed. It no longer had to be a thick, defensive barrier. It could become a delicate screen of colored glass. That was the true secret. The Gothic structure was a skeleton, but made of stone. It moved the forces outside. The flying buttress took the strain, letting the interior become an enclosure of light and air. The aim was spiritual, to make a heaven on earth, a container for sacred light, but the engineering was utterly practical. It was the most efficient method anyone had found to build tall with heavy material. And this knowledge spread. Wealthy merchants and nobles saw those spires aiming for the sky and wanted some of that prestige for themselves. In places like San Gimignano, they built tower houses, these stone needles of personal authority. They used simpler versions of the ideas, thick base walls tapering up, internal vaults, to construct domestic fortresses that ruled the city skyline. The drive to build upward wasn't just about solving a space problem anymore. It was about status, it was about defense, it was a statement of your position in the world. The Gothic skeleton showed that with the right support, even stone could be made to reach. But a city built of stone and timber, no matter how cleverly designed, faces a more ordinary, relentless danger. What happens when you pack thousands of people into a tight vertical space, and the water underground is foul, and the waste has no place to go? The vertical city needed something unseen. While towers went up, the real foundation was below ground, or sometimes carried above on arches. Water. A reliable supply wasn't just convenient. It was the one thing you had to have for thousands to live stacked together without getting sick or watching everything burn down. The secret was a hidden system. Conduits, pipes, public fountains, turning a natural thing into a managed utility. This was infrastructure at its core. Cities didn't just sit by rivers. They found ways to bring that water up and into their heart. London's conduit system. Starting in the 13th century, they built lead pipes fed by springs miles outside the walls. Those pipes channeled water to a central cistern, the Great Conduit, in Cheapside, and from there it was distributed, and this was public. Conduits and fountains became communal hubs. In Siena, the Font Gaia, the joyful fountain, it was more than a sculpture. It was the end point of a vast network. 25 kilometers of tunnels, the Bettini, sloping gently from distant springs into the main square. The engineering was precise, a constant, gentle gradient, flow without pumps, just gravity. The water filled different basins, one for drinking, another for animals, a third for washing. This was organized public health. A clean, dedicated source meant less reliance on contaminated wells or filthy rivers downstream from tanneries. The impact on health was profound, even if they didn't understand it in modern terms. It let a dense population live closer together with less constant threat from waterborne illness. But maybe the greater gift was security. Fire was the nightmare for every timber-framed, thatch-roofed city. A reliable public water supply meant bucket brigades had a chance. It meant a blaze in one packed street didn't have to end an entire neighborhood. Those fountains gave city planners a crucial confidence. They could allow denser construction, let those jetted buildings lean closer together, knowing there was a tool for containment. That water network was the lifeblood. It let the vertical city be more than a precarious stack of wood and ambition. It made it sustainable, livable. But even with clean water and fire management, a towering city of stone and timber created one final, unavoidable byproduct. What did they do with everything nobody wanted? A city that builds up has to find a way to send things down. All those people in towers, in crowded buildings, they create a constant flow of what they don't need anymore. The sanitation problem, without an answer, the vertical city would have choked. It would have been filth and illness. The medieval solution was infrastructure built into the walls. The garderobe, it was more than a privy. It was a vertical chute, an architectural feature. In a stone castle or a wealthy house, the garderobe was a small room set into an outer wall. A wooden seat over a hole, and that hole opened into a long, straight shaft, dropping all the way down to the ground, or into a basement or a river. The design was clever. The shaft was lined with smooth stone to prevent clogging, and it was ventilated. A small opening near the top would draw air upward, pulling smells out. Away from the living quarters, a primitive exhaust, you can still see the legacy. Those stone projections jutting out from a wall high up, that's a corbelled garderobe. Built out from the main structure so the chute falls clear of the foundation. Its placement was a major part of the floor plan. For larger communities like monasteries, the system scaled up. The reredote, a long hall built over a channel of flowing water, a series of seats along one wall, a communal facility but with remarkable engineering. The water below, diverted from a stream, would constantly carry waste away. This wasn't modern plumbing, but it was systematic, managed. It recognized waste wasn't a problem to ignore. It was a logistical challenge solved with design. In cities, many garderobe chutes emptied into deep cesspits, cleaned out periodically. Luckier ones might drain into a moat or an underground conduit. The point was removal, concentration, keeping it away from the living spaces, away from the water supply. This infrastructure, for all its simplicity, made high-density living possible. It prevented the nightmare of waste just being tossed into the street from upper windows. That practice would have turned the narrow lanes into toxic sewers. It was a direct physical response to vertical life. By channeling waste downward and away, these chutes let the city grow upward. They solved a basic, messy human need with stone and gravity and foresight. And with that fundamental problem managed, the medieval city could turn its ambition to something grander, not just building tall, but building a community in the sky. A city built from stone and timber needed another kind of skeleton, one you couldn't see. For every physical beam holding up a building, there was an invisible rule holding the city together. The law, the vertical city, was this delicate balance of ambition. Your right to build higher couldn't erase your neighbor's right to light, to air, to a view of the sky. That was codified in a principle called ancient lights, a customary right recognized for centuries. If your window had received daylight for 20 years, that light was yours. Your neighbor couldn't put up a new wall and plunge your home into permanent shadow. This wasn't just courtesy, it was enforceable. It created a legal dance. A builder planning an upper floor had to calculate not just weight but sight lines. How would this new structure affect the light next door? This invisible grid of rights and obligations shaped the skyline as much as any mason. It prevented a chaotic crush of stone that blocked all the light. It forced a kind of urban civility into the architecture itself. So even as buildings reached up, the street below wasn't lost to perpetual twilight. This legal framework extended to the very concept of air. The space above your property wasn't empty. It was an asset. You owned a column of air from the ground to the heavens. That idea of air rights is profoundly medieval. It meant that when a builder created a jetty, that overhang wasn't stealing public land. It was exercising a right to use the air above the street. A right attached to the property below. That legal clarity was everything. It made investment possible. If you were going to spend a fortune on a taller, timber-framed house, you needed to know your overhang was secure. That your neighbor couldn't suddenly demand you tear it down. The law provided that security. It turned risky ambition into a calculated venture, and the shape of the land itself encouraged this vertical thinking. Look at a medieval property map. You see burgage plots, long, narrow strips of land like fingers stretching back from a narrow frontage on the main street. That was a deliberate design. The frontage on the public thoroughfare was the most valuable piece of the entire plot. That's where business happened. That's where you were seen, so you built your shop, your workshop, right on that front line, but the plot was narrow. To get more space, you couldn't build wide. You built deep, and then you built up. The burgage plot was a factory for vertical architecture. It dictated the form, a narrow face on the street, but a tall, deep body behind it. The law also managed the points where ambition met ambition. The party wall, a shared wall between two properties, was governed by intricate custom. Who maintained it? Who could attach beams to it? If one house was leaning dangerously, was the owner of the stable wall next door obligated to help shore it up? Often the answer was yes. Your property's stability was legally tied to your neighbors. This created a web of mutual responsibility. It meant the city wasn't a collection of isolated towers, but a single, interdependent organism. Your security depended on the soundness of the structure beside you. This social scaffolding, ancient lights, air rights, burgage plots, party wall agreements, that was the true foundation. It provided the predictability, the trust. It meant a master carpenter could look at a narrow plot on a crowded lane and know with certainty exactly how high he could build, how far he could jetty out, and what his obligations were to the homes on either side. The physical city of wood and stone could only rise because an invisible city of law and custom held it steady. And with that legal safety net in place, the vertical city could pursue its ultimate expression, not just in houses and shops, but in structures that aimed for something beyond commerce or shelter. The most dangerous part of a medieval house was also its center. For a long time, the hearth was the heart of the home, just a fire pit in the floor with a hole in the roof for the smoke. That setup determined everything. You had one big hall. Everyone lived around that central fire for warmth, for cooking. The smoke would rise. It would gather along the ceiling before drifting out. That left a haze. It coated the beams in soot, and it put a limit on the space above. That hall was hard to divide. The heat and the fumes made lofts, upper floors, almost impossible to use. The whole house was organized around this one source of light and danger. The risk was always there. Sparks from an open fire could jump to the rushes on the floor, or to the timber walls. In a city of wooden houses packed close together, one accident could doom a whole neighborhood. The change started slowly, in stone castles first, in monasteries. Then it reached the everyday home, the masonry fireplace, built into a wall with a proper chimney. It seems obvious now, but the effect was deep. By putting the fire inside a stone box and sending the smoke up a dedicated flue, the fireplace fixed two things at once. It made heat safer, and it made heat movable. You weren't tied to the middle of the room anymore. The fire could go to the edge. Builders started putting fireplaces against outside walls. The stone back and sides contained the heat. The chimney, a shaft built inside the wall, carried the smoke straight up and out above the roof. That was a revolution for interior space. Suddenly, you could subdivide the great hall. You could have a fireplace in a private room on the ground floor. And because the flue was inside the wall, you could build another fireplace right above it. On the next floor, a single chimney stack could serve multiple hearths, one on top of the other. This made upper stories livable all year, no more shivering in a smoky loft. A room on the second or third floor with its own fireplace became warm, desirable, private. The value of vertical space went up fast. Adding a floor wasn't just about more room. It was about more comfortable room, it was about status. A family that could afford several fireplaces was sending a message. The safety impact was huge. The masonry fireplace cut way down on the chance of a stray spark setting the house on fire. The fire was boxed in. A well-built chimney flue kept heat away from the wooden beams. That one innovation gave city people new confidence. They could build those tall timber houses with jetted overhangs and sleep a little better, knowing the main danger in the home was now contained. The fireplace, set in the corner of a room, became the new social center. It allowed for smaller gatherings, more intimate ones. It created privacy inside the home for the first time. It turned vertical living from a compromise into a luxury. The chase for light and air and space now included the chase for warmth, and with that comfort secured, the medieval city faced its last big challenge. A human one. How do you move through this vertical world? How do you connect all these layers when every step up is a fight against gravity? The fireplace made living vertically comfortable, but it didn't make it safe. Safety from the outside world required something else. The medieval answer was a home that was also a fortress. In places where law was thin and conflict was constant, daily architecture took a more severe form. The tower house, it wasn't just a tall building, it was a statement carved in stone, a declaration that security meant going up and pulling everything you valued up with you. The principle was brutal efficiency. Consolidate every function of life and defense into the smallest possible footprint, a vertical column of survival. You see this stark logic in the Scottish borders or the hills of Tuscany. A simple rectangle of stone, 3, 4, sometimes 5 stories high. The ground floor was for animals or storage, a vaulted cellar with thick, windowless walls. The only entrance wasn't at ground level. It was a doorway set high on the second story, reachable only by a removable wooden ladder or a narrow stone stair that could be defended. To enter, you were vulnerable. You had to climb up into the mouth of the stronghold. Each floor above served a purpose, stacked like tools in a box, the hall for living and eating. Private chambers above that, storage at the very top beneath the roof. A narrow spiral staircase connected them all. It wound clockwise, so a defender retreating upward could wield a sword in their right hand with full range, while an attacker climbing below would have their weapon arm cramped against the central stone column. Every detail was tactical. The roof itself was a weapon, a flat fighting platform ringed by battlements. From here, a lookout could see for miles. An approaching threat gave hours of warning. And if a fight came to the walls, defenders could rain stones down on anyone below. The tower was an instrument of surveillance and control. It dominated the landscape visually, a constant reminder of who held power. For the family inside, it was a world in miniature, a self-sufficient vertical village. They could retreat inside, pull up the ladder, and withstand a siege. With stores of grain, a well dug deep into the lower floor, and a hearth for warmth. This was the ultimate integration. Military and domestic infrastructure weren't just neighbors. They were the same thing. The wall that kept the wind out also stopped arrows. The staircase that led to bedchambers also served as a choke point. The tower house proved that in an uncertain world, height wasn't about prestige alone. It was a practical equation. Elevation equaled security. It provided a clear line of sight and a clear line of defense. To build up was to gain control over your immediate environment. To see danger coming from far away and to force any challenger to fight gravity as well as your guards. This defensive verticality shaped entire communities. In Italian city-states like San Gimignano, rival families built these stone needles higher and higher, competing for dominance in the skyline. Their towers weren't just homes. They were military assets, status symbols, and safe deposit boxes for wealth, all in one soaring structure. The lesson was written across the horizon. In the medieval mind, safety was not found in spreading out. It was found in consolidating, in fortifying, in rising above. The tower house was the purest expression of a world where peace was fragile, and your greatest security was the height of your own walls. But this drive to build ever higher for comfort or for defense eventually met a natural limit, a force that didn't care about battlements or clever joints. Commerce needed its own vertical architecture. Homes went up for light, for safety, but the marketplace went up for profit, for prestige. The real engine for building tall wasn't a king. It wasn't a bishop, it was a merchant, and that ambition turned the city center into a layered world, a world of business. Take the cloth hall at Ypres. From outside, it looks like a cathedral to trade, a huge rectangle longer than a football field with an elegant bell tower on top, but the real genius was inside. It was a vertical organization of commerce. The ground floor was an open arcade, a covered market. That's where they'd inspect and sell bolts of wool and linen. Protected from rain, from sun, that space hummed with daily deals, but the building didn't stop there. Above that exchange were floors of offices, meeting halls. Secure storage. The guild officials who regulated the cloth trade worked right over their marketplace. The most valuable finished goods were stored upstairs. Safe from damp ground, safe from flood or theft. This was efficiency built in stone. Production, sale, regulation, storage, all stacked in one monumental structure. That model spread. In Bruges, the belfry over the market square was more than a clock tower. It was the city's strongbox. The vaults on its lower floors held the municipal charters. The treasury, the city seals, the bells at its summit regulated the working day. They signaled the market's opening, the market's closing. To control the height of that belfry was to control the commerce of the city itself. Guildhalls followed this logic. These weren't hidden workshops, they were towering advertisements for the wealth and power of butchers, weavers, goldsmiths. Their facades were carved with symbols of the trade. Their great halls were up on the upper floors, venues for feasts and meetings, lit by enormous windows that showed off the guild's prosperity to the street below. Their height was a direct reflection of economic influence. This commercial verticality solved practical problems. It drove architectural innovation. Storing heavy bales of wool or barrels of wine on an upper floor needed strong support, wide-span support that pushed carpenters to develop better floor joists. Better trusses. They created vast, open interiors with no columns in the way. Grand ceremonial staircases became a necessity. They let guild members ascend in procession to their halls. A simple change in level turned into a ritual of status. The need to move goods vertically led to sturdy internal hoists, pulleys, early freight elevators built right into the building. The result was a city center that worked in 3 dimensions. Street level was for movement, for display. The first and second floors were for secure transaction. For administration, the attics and towers were for safeguarding capital, goods and records. This stacking centralized economic life. It made the city a more potent engine of trade. You could arrive in a foreign city, walk to its main square, and immediately understand the hierarchy of power by looking up. The tallest, most ornate secular building was almost certainly the heart of commerce. In the end, the medieval skyline was a graph of its priorities. Spires pointed to heaven, tower houses spoke of earthly power, and the towering guild halls and market halls charted the undeniable rise of money. A tower is a statement, but a staircase is a conversation. It asks you a question. How do you move through a world that's built on top of itself? The answer wasn't just steps. It was about flow, a hidden system of circulation, making the vertical city work from the inside out. The most elegant solution came from geometry, the spiral staircase inside a stone turret. It's a masterpiece of compression, a helix of steps winding around a central column. Each tread is a wedge, wider on the outer edge, tapering to a point at the center. That design solved two problems. It saved an incredible amount of floor space. A straight flight needs a long, open run. A spiral just needs a round shaft. And it created incredible strength. That central column acts as a spine. It bears the load of every step and the people on them. The spiral itself is a natural brace. It resists sideways sway. For a defender in a tower, it was a tactical funnel. For a monk in a cloister, a meditative path upward. Even the direction of the turn held meaning. In many fortifications, the stairs spiral clockwise as you ascend. That gave a right-handed defender above the advantage room to swing a sword. The attacker's arm would be blocked by the central pillar. The staircase was never just a way up. It was architecture with intention. In an everyday merchant house, circulation was more pragmatic. Steep, straight ladders connected floors through trapdoors. They were space-efficient, but they dictated movement. You couldn't carry a large piece of furniture up a ladder. You sent up sacks of grain or bolts of cloth. The flow of goods was limited by the passage itself, and that shaped daily life. Heavy things stayed low. Lighter, more valuable things or people went up. The placement of these passages carved the social map of the home. In a grand townhouse, you'd find two separate systems. The main staircase, often wide and decorated, sweeping up from the formal entrance hall. That was for the family, for guests, for display. Then, hidden in the back, a narrow, steep service stair, a wooden tunnel for servants, for firewood. For kitchen supplies, the two streams of life, the elegant and the essential, flowed through the same building but never met. Your path defined your place. To climb the grand stair was a ritual. Each step reinforced status. To use the back stair was to be part of the machinery, invisible but necessary. This internal circulation was the silent rhythm of the vertical city. It decided how food got from the cellar kitchen to the third-floor dining room, how fuel reached the hearths, how waste was removed. Efficient flow made a tall house livable. A poorly designed one meant constant, exhausting labor. The sound of footsteps on different stairs told the story of the day, the hurried clatter of servants on wood in the morning. The measured tread of the merchant on the main stair at noon, the sigh of the final climb to the bedchamber at night. These vertical paths were the glue. They tied the stacked layers of home, of workshop, of warehouse into a single, functioning organism. Without this hidden network of ascent, the ambition to build upward would have collapsed. Collapsed under the sheer weight of daily inconvenience. The city learned to move not just across but through itself in a constant, quiet climb. The roof. It was the final piece, high up above everything else. It kept the rain out, the snow off, but it was more than that. It was a system, a hidden structure of timber. And for a large hall or a wealthy home, the problem was the space inside. You wanted a big room up there, open, with no columns in the way, but a heavy roof needs support. You can't just let it sit on the ceiling. The joists would bend and then they'd break, so the carpenters built a bridge, but in the air, the crown post roof. Think of a great hall, two long timber walls, and up in the dark between them, a series of wooden frames. Each one is a truss. The peak is the roof's ridge. And from that peak, two long beams slope down to the walls. That's the basic shape, but the weight of the roof pushes outward. It wants to spread the walls apart. So they add a beam, a tie beam. It connects the bottom ends of those sloping beams. It ties the triangle together. It holds that outward push in check. And then the crown post. From the middle of that tie beam, a single vertical post goes straight up. It meets another horizontal beam higher up, connecting the two sloping rafters. That's the collar beam, and this post, the crown post, it's a central pillar, but it does more. From the top of this post, 4 angled braces reach out. They connect to the collar beam and to the principal rafters. These braces are the key. They create a rigid network. They triangulate the whole frame. They lock every joint. They take the load from the heavy ridge, send it down through the post, and then out along the tie beam to the walls. The strength is incredible. And the space below the tie beam is completely open. No columns, no walls. All the roof's weight gets channeled down the braces, down the post to the outside walls. The whole interior is free. This made the later hammerbeam roofs possible. It turned the attic from storage into the building's structural core. In barns, it meant you could store hay without anything in the way. In Guildhall, you got a vast chamber. In a home, a top-floor room could have a grand, clear ceiling. This was the final piece. The foundation carried the weight. The walls directed it, the fireplace gave heat, and the crown post roof, that wooden lattice in the gloom, it carried the sky. It showed that building upward wasn't just about stacking height. It was about creating a vessel of space below, defined not by the mass of stone, but by the careful lack of support. The city grew tall not by piling weight, but by mastering the frame. Turning force into form, and with that, the vertical city was finished, a working whole from cellar to rooftop. But this dense, towering world of wood faced one natural enemy. An enemy that could erase centuries of work in a moment with a single spark. That wooden skeleton, that stone spire, it all started somewhere else. The city couldn't feed its own ambition. It had to reach outward, command a landscape. Every beam, every block of stone was a link in a long, hidden chain. The supply chain was the silent partner. An infrastructure of extraction, of logistics, a system that moved mountains one cartload at a time. For stone, the journey usually began with water. Rivers were the medieval highways. A quarry might be miles away, but if it sat on a riverbank, the heavy work was half done. Blocks were rough cut at the site. Loaded onto flat-bottomed barges, these vessels, poled or pulled by teams along towpaths, could carry immense weight. They spared the fragile roads. The stone arrived at the city's wharf, a riverside workshop district. Master masons would inspect it. Their skilled workers, the stonecutters, would finish each block, carve it to precise dimensions, using wooden templates as guides. Then it was hoisted into place on a growing wall. This wasn't just transport. It was a phased manufacturing process spread across geography. The quarry provided the raw mass. The river carried the burden. The city yard applied the final, intelligent form. Timber had a different origin, slower. It came from a managed landscape. The great oak beam for a merchant's house began its life decades earlier. A century, even. Woods weren't just wild forests. They were cultivated like a crop. Lords and monasteries maintained wooded estates. Foresters marked specific trees, the right height, straight grain for future building. They knew oak cut in winter, when the sap was down, resisted rot better. The felling was a community event. Using axes and two-man saws, workers would bring the giant down. Then the real transformation began. The bark was stripped. The trunk was squared with broadaxes, becoming a rough-hewn timber. But moving a 50-foot oak beam weighing several tons over rutted tracks, the answer was often to let it slide. In winter, they'd drag timbers over frozen ground or snow, reducing friction, or they'd use a heavy cart pulled by a team of oxen. Their slow, powerful pace suited the massive load. For long distances, rivers again became crucial. Timbers could be floated downstream in rafts, guided by boatmen with long poles. This journey from forest to building site could take months. At the city gates, the specialized trades took over. The carter negotiated the final journey through narrow lanes to the plot. The sawyer, operating a saw pit, would take the squared timber and slice it into planks. One man stood in a pit below, another on a platform above, pulling a long, vertical saw up and down through the wood. Exhausting, precise work. The sawyer's skill determined the quality of the floorboard, the paneling, the joist. These networks were often controlled by powerful guilds. The Carpenters' Guild, the Masons' Guild, the Guild of Carters. They set prices, regulated quality. Manage the flow. This organization was crucial. It meant a master builder in London or Bruges could order a shipment of stone from a quarry he'd never seen, or specify oak from a forest 50 miles away and have a reasonable expectation of its arrival. The supply chain created predictability in an unpredictable world. It turned local ambition into a regional economy. Without this constant, reliable bloodstream of material flowing into the city, the rapid vertical growth of those centuries would have stalled. The skyline was built on stone and timber, but also on trust, on contracts, on the sweat of bargemen guiding heavy cargoes around a river bend at dawn. This logistical web made the physical city possible, but the people who designed it, who calculated the stress on a jetty or the angle of a flying buttress the city's vertical rise, required a new kind of mind. A thinker who could translate vision into load-bearing reality. The city's deepest fear wasn't invasion, it was itself. A single spark in that canyon of wood could erase a century in one night. So alongside the visible city of stone and timber, another system grew, a system of rules, a shield against catastrophe. Survival didn't just depend on how you built. It depended on what you built with. This was the infrastructure of prevention. The roof was the most dangerous part. Thatch dried reeds or straw. It was cheap, it worked, and it was a perfect tinderbox. A wind-borne ember from a neighbor's chimney could settle in, smolder, and then erupt. The response was law. Cities began to legislate the skyline. In London, after a terrible fire in the 12th century, ordinances appeared. They encouraged, then required, clay tile or slate. In Nuremberg, the council went further. Decrees mandated tile roofs in the city center, and they dictated the installation. The gaps between tiles had to be sealed with mortar. This wasn't about looks. It was about creating a continuous, fire-resistant shell over the whole urban canopy. The investment was collective. Tile and slate were heavier, more expensive. They needed stronger roof frames. This was a public safety tax paid by homeowners for the good of all. The logic was inescapable. In a dense, vertical community, your roof wasn't just your shelter. It was your neighbor's ceiling. A fire on one building would leap to the next, climbing the wooden jetties like a ladder. Your material choice was everyone's business. The municipal code turned that social contract into law. The walls got similar attention. Common infill was wattle and daub, a lattice of sticks plastered with clay, dung, and straw. On its own, it could burn, but the next layer was crucial, a coating of lime plaster. When fire hit it, the plaster would harden, form a brittle, protective crust. That could slow the flames, sometimes long enough for a bucket brigade to respond. Builders started to favor brick nogging, filling the timber panels with brick, which was even more resistant. These weren't stylistic choices, they were calculated upgrades for survival. Regulations extended to the gaps between buildings. Codes began to specify minimum distances, or require party walls to be raised above the roofline to act as fire breaks. These were the medieval equivalents of firewalls, attempts to compartmentalize the city, to create barriers a blaze couldn't easily cross. This web of rules and materials formed an invisible shield, a distributed system of defense built into every home and street. The aldermen who passed these laws, they were early urban planners. They understood the city's incredible vertical density came with an incredible shared vulnerability. Their solution was to harden the whole organism against its own risk. They turned building materials into civic infrastructure. Every tiled roof, every plastered wall was a node in a network of mutual protection. It was a profound acknowledgement. In a world built upward, safety could never be private. It was a collective architecture of care written in clay, slate, and law. And while these rules managed the structure, the life inside it, the movement of people, goods, ideas through this vertical maze, that required a different kind of order. Even food learned to climb. In a city where land was measured in feet, not acres, a traditional farm was impossible, but hunger is a powerful designer. It forced households to look at every vertical surface and ask what it could grow, what it could hold. The answer was a quiet revolution. Walls, towers, rooftops became sources of sustenance. Take the dovecote. From the outside, it often looked like a small, round tower. Inside, it was a layered apartment building for birds. The interior walls were lined with hundreds of small nesting niches made of pottery or carved stone, arranged in rows from floor to ceiling. A central wooden pole with perches let the pigeons land and ascend to their homes. This was a vertical farm for protein. Pigeons provided a reliable source of meat and eggs, especially in winter. Their droppings, collected from the floor below, were valuable fertilizer for whatever small garden plots existed. The dovecote was efficient. It used a small footprint to produce a disproportionate amount of food. But it was also a status symbol. In many places, the right to keep doves was legally restricted to lords or certain landholders. A tall dovecote on your property wasn't just a larder. It was a declaration of privilege written in stone and feathers. For those without that right, the garden wall offered another solution. Instead of letting a sunny south-facing wall go to waste, they trained fruit trees against it. This practice was called espalier. It turned a flat surface into a living tapestry of apples, pears, or peaches. The wall did several jobs at once. It reflected heat, creating a warmer microclimate that helped fruit ripen. It provided support for the branches, which were pruned and tied into elegant, space-saving patterns, and it protected the tree from wind. A single wall could nourish several trees, where a traditional orchard would have needed a large patch of open ground. This was food security built into the architecture itself. And then there were the rooftops. On the flat tops of towers or the leads of larger homes, you might find container gardens. Herbs grew there: thyme, rosemary, sage, parsley, in pots or built-up beds of soil. These were the essential flavors and medicines of daily life, plucked just a flight of stairs from the kitchen. A rooftop garden had practical benefits too. The soil and plants provided extra insulation for the rooms below, cooler in summer and warmer in winter. They absorbed rainwater, reducing runoff. In the densest quarters, this might be a household's only private outdoor space, a tiny patch of green in a skyline of wood and stone. These adaptations were small in scale but profound in implication. They showed a mindset of total integration. A building wasn't just for shelter or commerce. Its walls could be a farm, its tower could be a coop, its roof could be a pharmacy. This vertical farming reduced a household's dependence on the uncertain markets outside the gates. It provided a buffer against siege, against poor harvests, against the high cost of transporting food into the crowded city. It made the vertical home more resilient, more self-contained. This agricultural ingenuity completes the picture. The medieval city wasn't just a stack of rooms reaching for the sky. It was a layered ecosystem. Water flowed through hidden conduits. Waste traveled down dedicated chutes. Heat rose from contained fireplaces, and food grew on sunlit walls and in high towers. Every human need, safety, community, cleanliness, warmth, nourishment, was met not by spreading out but by building up, by thinking in 3 dimensions. The city had learned to live with itself in a delicate, astonishing balance. But this balance, this whole intricate system of wood and stone and law, rested on one final, fragile foundation. The minds that conceived it, the master builders who held the secrets of gravity in their hands and who passed them down not in books but in the language of tools and timber. Sound was this layer of the city you couldn't see. In those narrow streets with the buildings leaning out, sound behaved differently. It didn't travel far. But it traveled up. A conversation down by a shop front would rise. It would climb the timber, slip through an open window on the 2nd floor, drift into a chamber on the third. The city was a visual maze, all that leaning wood, but it was also an acoustic canyon. Noise got channeled, amplified, reflected, that created an invisible information system. As vital as the water pipes underground, the public broadcast system was bells and voices. The parish church bell marked the hours. Its deep toll would roll down the streets and up into the attics, telling everyone at every level when to pray, when to rest. Then came the specialized calls, the watchman's cry from the corner after curfew, "All is well." A blanket of auditory safety, heard by the merchant in his bedchamber and the servant in the garret. The street crier was the human newspaper. His announcements, proclamations, prices, lost items, they weren't projected across a square. They went into the vertical shaft of the street. He didn't need to reach every lane. His voice would carry up. Neighbors would lean from their windows and repeat the news to those further back in the building. Information flowed vertically, like water down a drain pipe. That constant sound created a deep community cohesion, sometimes intense. You were never truly alone in your vertical home. The sounds of daily life were a shared tapestry. You'd hear the clatter of a loom from the workshop below, laughter from a family meal across the street, a baby fussing in the room above yours. It was a passive, mutual awareness, a kind of social glue. If an elderly resident on the top floor fell ill, the unusual silence might prompt a neighbor to check. If a shopkeeper had a windfall, the celebratory noise told the story. Gossip didn't just travel door to door, it traveled window to window, floor to floor. But that intimacy had another face. It was also informal surveillance. Private conversations, if not hushed, weren't private at all. Arguments, business dealings, family secrets, they could become public performance for anyone in earshot. This acoustic reality shaped behavior. It encouraged discretion, enforced social norms through the gentle pressure of being overheard. You lived with the understanding that your home wasn't an isolated box. It was a permeable cell in a great-sounding hive that enforced a certain civility, a certain conformity, because the walls themselves seemed to listen. The result was a social world knitted together by sound as much as sight. The vertical city was a resonant chamber. Its acoustics turned every street into a communal nerve, carrying the pulse of public life upward and the murmur of private life outward. That shared sensory experience, that constant low hum of connectedness, is what made a towering stack of individual homes feel like a single neighborhood. News from the docks could reach a top-floor weaver's studio almost as fast as it reached the tavern on the corner, carried on a current of air and human voice. In the end, the city's greatest infrastructure might have been the very silence it so rarely knew. The ambition to build upward always started with a fight against what was below. The ground itself was the enemy. In cities built on marsh, on reclaimed riverbanks, on soft silt, a tall stone building would sink, it would tilt, it would crack. So before the first stone was laid, builders performed a hidden act of conquest. They drove the city's roots deep. They used piling. It was a brutal process. Workers took long, straight trunks of oak or elm, sharpening one end into a point. Using a heavy ram, a weight lifted by ropes and dropped, they drove these timber piles straight down into the soft earth. They hammered them past the muck, past the peat, until the tip hit something solid. A layer of compact gravel or dense clay or bedrock, that was the goal. To bypass the unstable and anchor into the reliable. Dozens, sometimes hundreds of these piles would be driven in a grid pattern across a building site. From above, it looked like a forest of wooden stakes submerged. Then came the platform. Across the tops of these piles, workers laid massive horizontal beams, locked together with joints or iron straps. This created a rigid wooden raft, a raft floating on a subterranean forest. The building's entire weight would now be distributed across this grid, transferred down through the piles. And finally, born by the firm layer far below, it was a bridge between the unstable surface and the solid deep earth. For work near water, like a quayside warehouse, they built cofferdams. Temporary walls of planks driven into the riverbed, sealed with clay. They pumped the enclosed area dry, creating a pocket of air in which to drive piles and lay foundations. It was like building a castle in an empty bathtub, then letting the river back in around it. Beneath many of these sturdy buildings lay another world. The cellar or undercroft, carved out of the ground beneath the timber platform. These spaces were cool, dark, and remarkably strong. Vaulted stone ceilings supported the floor above. They became the city's hidden utility layer, perfect for storage. Barrels of wine, sacks of grain, trade goods that needed to stay cool and dry. In places like London's waterfront, these undercrofts became taverns. Their low ceilings and thick walls creating a cozy, subterranean social space. This was the city adding a valuable negative floor. It wasn't about height, but depth. It effectively increased the usable space of a narrow plot without adding a single story to the skyline. This hidden work, the forest of piles in the dark earth, the silent stone vaults below the street, was the uncompromising foundation of everything. The soaring Guildhall, the jetted merchant house, the towering spire, they all depended on this unseen victory over instability. The city's vertical reach was literally built on a secret, inverted forest. Its roots gripping the deep earth so its branches could dare the sky. Repetition became its own kind of genius. A city needs to house thousands quickly. So it stops thinking about one ornate tower. It thinks about one brilliant unit, and then it repeats that unit down an entire street. That was the modular secret. The row house, a vertical growth strategy built on sameness, efficiency in every dimension. Builders would get a long, narrow strip of land along a new street or a canal. And instead of designing a dozen unique homes, they designed one, a narrow frontage, sometimes just the width of a single window and a door. That frontage was everything. Your public face, your address, but the house didn't stop there. It went deep, stretching far back from the street, following that long, thin plot of land. And of course, it went up 3 stories, 4, 5, creating a vertical column of living space on a minimal footprint. The real infrastructure was the shared wall. Each house built snug against its neighbor, sharing a common wall from foundation to roof that did several things. It saved material. One wall served 2 homes. It was stronger. A continuous wall of houses supported each other like books on a shelf, and it was efficient to heat. With only the front and back walls exposed, the shared walls trapped warmth. A row of houses became a thermal mass, a collective barrier. Look at the rows in Chester, in England. The module took a turn there. The ground floor was often a lower arcade, a covered walkway for shops, but the main living floor was the first floor, built directly above, accessed by stairs from the street, that created a continuous elevated gallery. A second-story street running the length of the block. The homes were modules, stacked vertically but also layered horizontally, a space-saving puzzle. The entire city block became one interconnected structure. In Amsterdam, the canal houses show the idea refined. Walking the Herengracht, you see a rhythmic streetscape. Narrow brick facades at a uniform height, each with a distinctive gable, but all following the same deep, tall plan. That uniformity was strategic. It allowed for rapid, predictable construction. During the city's explosive growth, a builder could replicate the same basic frame and shell over and over, only customizing the decorative gable top for a family's individuality. This was mass production centuries before the factory. The result was a streetscape of density and order, a single long street holding dozens of families, each in their own vertical column of rooms. It maximized housing per meter of road, per meter of waterfront. It created a clear, dignified urban edge. The approach was scalable. You could add another unit to the end of the row. You could rebuild one house without destabilizing the neighbors. The row house turned domesticity into a collective architectural wall. A wall of habitation, making the city not a collection of buildings but a continuous fabric, a living tapestry woven from identical threads. But this dense, repetitive fabric created a new pressure. A social pressure. You live in a vertical stack, cheek by jowl with dozens of other families. How do you prevent friction from tearing the community apart? The answer wasn't in the architecture. It was in the quiet, daily rituals that flowed through it. A cathedral spire was a prayer in stone. It was also a municipal budget line. Those great vertical structures, they weren't acts of solitary genius. They were acts of collective will, paid for by the community. The grand projects, the walls, the bridges, the water conduits, these were public works. And they needed a public treasury, taxes on goods, tolls on bridges, donations from guilds and wealthy citizens. All of it flowed into a civic fund, not for private gain but for shared stability. That was the critical transaction. The community invested in a stable platform, and on that platform, private ambition could build upward, take the city wall. It was the ultimate public good. Its construction could take generations, cost a fortune, but once it was complete, it sent a signal. Inside this stone ring, your investment is safe. That security was the bedrock. A merchant wouldn't risk his life savings on a tall stone house if he thought an army could overrun the town next season. The wall provided the safety, the psychological safety that made permanent vertical architecture a rational choice. It turned speculative building into a long-term investment. The same logic applied to water. A private citizen could dig a well, but a well could run dry. It could become contaminated. The public fountain was different. Fed by miles of engineered conduits, it was a promise, a clean, reliable source for everyone, forever. That infrastructure made high-density living viable. It reduced the constant threat of illness from tainted water. A family in a cramped, 4-story tenement could thrive because the city had solved the water problem at a civic level. Their private vertical home was made livable by public horizontal engineering. This relationship was symbiotic, a feedback loop. The taxes that built the wall and the fountain came from the wealth generated by the merchants and artisans living in those tall houses. Their commercial success filled the city's coffers, and that money was reinvested in newer infrastructure, a fortified bridge to secure a trade route, an expanded quay for more ships. That new infrastructure, in turn, boosted trade. It raised land values. It encouraged more ambitious private building. The soaring Guildhall was a testament to private wealth, but it stood on a street made safe by public guards, cleaned by public ordinances, fed by public water. The lesson was this: the medieval city, often seen as chaotic, operated on a sophisticated understanding. Private verticality didn't happen in a vacuum. It thrived on a foundation of shared, publicly funded infrastructure. The spire needed the sewer. The merchant's tower needed the wall. This wasn't a government imposing from above. It was a community recognizing their individual fates were woven together. They taxed themselves to build the common bones, the skeleton of walls, the veins of water, the sinews of bridges. Upon that, the muscle and flesh of private life could grow strong and tall. Their vertical skyline was a monument to horizontal agreement. Reaching for the sky begins with a shared commitment to the ground. In 1300, Paris had maybe 200,000 people inside its walls. By the 1400s, that was over 300,000. The walls hadn't moved. They were the same walls from a century before, the same island, the same riverbanks. Every new person, every child had to fit inside that same stone ring. That was the math, a demographic pressure cooker. The countryside wasn't empty. It was moving. Families pushed off land by new farming. younger sons with nothing to inherit, artisans looking for a bigger market. They came in waves for work, for safety. And the city took them in. It had to. The first effect was on the price of dirt. A small plot near a gate or on a busy street became a fortune. Its value wasn't in what grew there, but in what you could build on it. And then above it, a merchant wasn't buying land for a garden. He was buying air, the right to build a column of space. That financial reality made the timber frame, the jetty, the party wall, all of it economically essential. The high cost of the ground forced you to maximize every inch above it. A straight wall was a waste. The jetty stole extra square footage from the public air, adding value to that impossibly expensive patch below. You see the crush in the records. In Florence, they started setting minimum street widths, not for beauty, but so carts could get through the human tide. They worried about fire, but also about movement. Overcrowding changed daily life. A tenement's shared courtyard, once for washing and children, became a crowded thoroughfare. The sound grew denser, a constant hum of voices and work pressing in from all sides. This density created new problems. How do you get clean water to a building with 8 families? How does waste from 5 upper floors go down one chute without creating a hazard at the bottom? Every infrastructural secret was an answer to that pressure. The public fountain network wasn't built for elegance. It was built because 1,000 private wells couldn't serve tens of thousands packed together. The laws about ancient lights protecting a window's sun became critical when your neighbor's new upper story could plunge your home into gloom. These weren't optional. They were for survival. The demographic tide forced a brutal creativity. It made the city experiment, adapt, layer system on system. This pressure also made a new social reality. Living vertically meant living communally. Your stability was tied to your neighbor's foundation. Your chimney smoke was their air. Your family's health was linked to the shared conduit at the end of the lane. The vertical city was a lesson in interdependence, taught by the physics of limited space and unlimited human want. The skyline of spires and gables wasn't a monument to escape. It was a monument to compaction, a collective response to the fundamental urban equation: too many lives on one small piece of earth. The towers of San Gimignano. They still cut the sky, a cluster of stone needles against the Tuscan hills. It's the medieval vertical city made real, a living museum. They called it the Manhattan of its time. At its peak, over 70 family towers stood here, a forest of stone declaring power. It wasn't just a city that grew tall, it was a city that weaponized height. Its story is where all the secrets converge. The first secret was the wall, a fixed defensive perimeter. The land inside was finite. As families grew, as fortunes were made, the only direction was up. That absolute land scarcity, that was the second secret, the relentless engine. But the drive wasn't just for space, it was for dominance, rival families. The Ardinghelli, the Salvucci, they turned architecture into a public scoreboard. Each new tower was a direct challenge. My tower must be taller than yours. A vertical arms race, a Cold War fought in quarried stone, applying the defensive logic of the tower house to an urban battlefield. The fuel for this race was economics. The ninth secret, San Gimignano sat on the Via Francigena, a major pilgrimage route, but its true wealth came from one crop, saffron, a spice worth more than gold by weight. It funded everything. The merchant families who controlled the trade didn't just want secure warehouses. They wanted monuments. The towers were their banks and their billboards. The commercial verticality of the Guildhall distilled into a domestic fortress. The ground floor might be a shop, a secure vault for saffron threads. The upper floors held living quarters. The very top was a lookout post, surveying the countryside, surveying the rival towers just a stone's throw away. Walking the streets today, you see the secrets etched in stone. The narrow lanes are canyons, buildings leaning close, their foundations limited by the original Roman grid. You can trace the party wall agreements, the invisible legal lines where one family's ambition met another's. The towers show the technical ingenuity. Thick bases tapering upward, internal vaults to distribute weight, all the lessons of managing gravity without a master blueprint. They even solved the water problem. Deep private cisterns catching rainwater from those towering roofs. A besieged tower needs its own supply. What makes San Gimignano the perfect case study is its preserved state. Plague and political decline froze it in the 14th century. The building stopped, the rivalry ended. What remains is a snapshot, a laboratory of vertical urbanism. We see not one secret but the entire system, the social competition, the economic driver, the technical solutions to building tall, the defensive imperative. All locked in a dynamic stone embrace. It shows us the vertical city wasn't an accident. It was a conscious choice repeated over and over until the skyline itself became the city's identity. The medieval dream of height made permanent. When a community looks up, it's often reflecting the very earthly pressures holding it together. The vertical city was ingenious, but it lived on a knife's edge. That same density that drove innovation also magnified every flaw. When a structure failed, it was catastrophic. The chronicles are full of towers that just fell. In 987, the great wooden bell tower at the Abbey of St. Gallen collapsed in a storm. The cause was usually the same. Builders pushed height beyond what they understood about the foundation. They built on ground that seemed firm, and then watched their creation sink on one side. The walls would spider web with cracks. Then came the final, thunderous descent. Each collapse was a brutal lesson, a lesson in geology, in load. It forced a more cautious approach, a deeper look at the earth before the first stone was laid. Those failures are why the piling techniques became so widespread. That submerged forest of timber, it was a direct response to tragedy, a hard-won secret written in the rubble. Then there was fire, the unconquered demon. For every new rule about roof tiles, there were 100 older buildings with thatch. A single careless moment with a candle, a spark from a forge, could undo a century of growth in one night. London's Great Fire in 1666 is the most famous, but it was preceded by countless smaller ones. Fires that erased entire neighborhoods. The regulations were a shield, but not an impenetrable one. In those dense timber canyons, once a fire took hold, it created its own wind. It would leap from jetty to jetty with terrifying speed. Bucket brigades from the public conduits were often helpless against that kind of fury. These periodic devastations were a grim tax on vertical ambition. A reminder that the city's greatest strength, its interconnected wooden skeleton, was also its most profound vulnerability. Recovery was always slow, a painful cycle of loss and rebuilding, each time maybe with a few more stone party walls, a few more tile roofs. The fight against fire was never won. Only managed, a constant negotiation with an elemental force, and then the human costs of that tight compression. The very infrastructure that made vertical life possible could also incubate hardship. When thousands are packed together, with waste flowing in shared channels and clean water a public commodity, the spread of illness becomes a geometric problem. Outbreaks could move through the vertical city with a speed unknown in villages. A poorly maintained garderobe chute could contaminate a well. Crowded living quarters, families sharing single rooms in tall tenements, let contagion jump from household to household with ease. The mortality records from these dense quarters tell a somber story. The urban promise of safety and prosperity was periodically shadowed by waves of loss. Waves that reshaped the community, and the same narrow, shadowed streets that fostered acoustic intimacy and neighborly watchfulness could also conceal desperation. Wealth lived stacked beside poverty. The merchant in his tall jetty house might look down on the crowded alley where the less fortunate sought shelter. That proximity, without always providing mobility, could breed tension. Crime was the dark counterpart to communal trust, petty theft to more serious conflicts. The city's guards and its laws were another form of essential infrastructure, constantly tested by the pressures of density. To look at these limits isn't to diminish the achievement. It's to understand its true nature. The secrets of vertical growth weren't magic formulas for a perfect city. They were a set of tools, constantly refined through trial and painful error. Every successful tower stood as a correction to a past collapse. Every new conduit represented a lesson learned from a past outbreak. The glorious, reaching skyline wasn't a static monument. It was a dynamic, fragile equilibrium, a balance struck daily between breathtaking human ambition and the stubborn, unyielding realities of physics, material, and human nature. The vertical city was always a work in progress, a magnificent, precarious answer to an impossible question. That forest of medieval towers, it's not a closed chapter. The roots are still alive, they run deep under our modern streets. The jetty, that theft of air, it didn't vanish, it evolved. In the 19th century, it came back as the oriel window. The bay window, projecting from a brick facade to grab more light, more space. Today, you see its purest descendant in the cantilevered balcony, a concrete or steel shelf extending from an apartment building. Claiming air rights with the same ambition but using reinforced concrete instead of timber braces, the medieval builders question how to gain space without more land. It gets answered every day. By architects around the world using the same principle. The legal framework is maybe the most direct inheritance, that medieval concept, ancient lights. Your right to sunlight after 20 years, it's embedded in modern property law. It evolved into easements, into rights to light, which still influence building codes in cities like London. And the idea that you own a column of air above your plot, that is the very foundation of modern air rights. It's why a developer in Manhattan can buy the unused airspace above a historic low-rise and transfer that development potential to a new skyscraper down the block. The entire financial logic of the modern vertical city, it rests on a medieval legal abstraction. Zoning laws themselves dictating how high and where you can build, they're the direct bureaucratic descendants of those communal agreements about party walls and street widths. We're still negotiating the same compact between private ambition and the common good. The structural secrets made the leap from stone to steel. The Gothic masons discovered that by using a skeletal frame, ribbed vaults, flying buttresses, they could build taller with less material. They redirected force. 19th century engineers faced the same puzzle with iron, then steel. How do you build a 10-story office building without making the lower walls 10 feet thick? The answer was the steel frame, a metal skeleton like the timber frame but immensely stronger that carries all the weight. The outer wall becomes a mere curtain. A skin of glass and masonry hung from the frame. This is the direct intellectual heir to the Gothic system. The flying buttresses job channeling thrust outward. It's now done by the steel girder and the deep foundation. The principle of load redistribution, creating a rigid skeleton to free the walls, that was a medieval breakthrough. It enabled the 20th century skyline. And the core challenge, the human one, it has never changed. Medieval planners grappled with the pressures of density, sanitation, water, fire, social friction, all within a fixed wall. Our wall isn't made of stone, it's economic and geographic reality. We face the same essential dilemma. How do we house more people, provide them with light and air and community on a limited piece of land? The medieval answers: public fountains, shared infrastructure, codes for materials. Those were their version of municipal utilities, building safety regulations. Our solutions are more technologically advanced, but the goal is identical: to make dense vertical living not just possible but healthy, safe, humane. Seeing this thread changes the story. The medieval city builder is no longer a figure from a distant, primitive past. He was a pioneering problem solver. Working in timber and stone with a startlingly modern mind, his infrastructural secrets, the legal, the social, the structural, they weren't dead ends. They were foundational chapters, early drafts in the ongoing, epic story of how humanity builds upward. Next time you look up at a glass tower, remember you're seeing the latest iteration of a very old dream. A dream first sketched in the leaning timbers of a crowded medieval street, where the only direction left to go was up. The city's silhouette became its signature. But it wasn't carved against a flat horizon. It was carved against the sky. That aesthetic came from necessity. The streets were narrow, deep cracks between timber cliffs. And light performed a daily drama there. Sunlight didn't flood these spaces. It arrived in slants and shafts, a precious commodity. It moved across plaster walls like a slow, golden clock. At noon, a brief, brilliant stripe might hit a shop front. By mid-afternoon, the canyon floor returned to a cool, blue gloom. This play of light and shadow wasn't an artistic choice. It was a mathematical result, jetted buildings leaning in, streets kept narrow to maximize the building footprints, but it created an atmosphere, an intimate mystery. Walking such a lane felt like moving through a living cathedral. Its vaults were leaning eaves and crossed timbers. You'd look upward from that shadowed path. The skyline wasn't a smooth line, it was a jagged rhythm. The repeated patterns of gables, like teeth in a comb, cut black shapes against the bright sky. Each jetty created a horizontal break, a step in the facade, so the building seemed to ascend in stages. That rhythm was the visual music of the modular city. The repeated row house, the standardized timber frame. From a distance, this created a texture, a bristling, uneven silhouette. It made the city look less like a collection of buildings, more like a single, complex organism, a mountain range crafted by human hands, and then, piercing that textured skyline, the spires, they were the exclamation points. Their vertical reach was an aspiration made visible, pulling the eye and the spirit upward. They gave the city a focal point, a landmark visible for miles. But their beauty was inseparable from their engineering. The delicate stone tracery of a Gothic window, the thing that filled the interior with ethereal light, was only possible because of the flying buttress hidden outside. The awe you felt standing before it was literally supported by a brilliant solution to a structural problem. The aesthetic was the expression of the infrastructure. This vertical environment reshaped how people saw their world and how they wrote about it. In literature, the city was often described as a labyrinth. A place where you could get lost not just on the ground but in layers of perception. The towering houses created a sense of enclosure, of being within something immense and man-made. Poets spoke of streets as valleys, of towers as peaks. The city became a new kind of nature, an artificial wilderness with its own rules and its own sublime beauty. That perception fed a growing urban identity. To be a citizen was to navigate this vertical realm, to understand its shadows and its sightlines. The lesson is that beauty often emerges from constraint. The medieval city didn't set out to create an aesthetic of verticality. It set out to solve a brutal equation: too many people, not enough land, surrounded by a wall. Every technical secret, the jetty for space, the timber frame for flexibility, the flying buttress for height, was a response to that pressure. Yet from those pragmatic, even desperate solutions, arose an environment of staggering visual power. An environment that defined the Gothic era and continues to haunt our imagination of the historic city: the cobbled street, the overhanging house, the distant spire. These aren't separate postcard images, they're interconnected parts of a single system. A system where the need for security, for space, for light, for commerce was solved by building upward. And in doing so, they accidentally built something that moved the human heart. They proved the most enduring forms of beauty often emerge when form is forced to follow the most urgent of functions. The vertical city was never finished. It was a living thing. It breathed, it settled, it decayed, and against that decay there was an army, not soldiers. Artisans, a thatcher on a rooftop weaving reeds into a watertight pattern, a mason on a scaffold picking out old mortar, pressing in new lime, a carpenter probing an oak beam with an awl, listening for the hollow sound of rot. This was the 24th system, the maintenance regime, a perpetual, cyclical labor, a form of living infrastructure. The work was constant because the materials were alive. Timber frames expanded with summer humidity. They contracted in the winter's dry cold. Those subtle movements over decades could loosen a crucial joint. Water was the eternal enemy, a single cracked roof tile, a blocked gutter on an overhang that could let moisture seep into a wall. The moisture would find the timber. And in the dark, it would invite the slow feast of fungi and insects. A building didn't fail in a day. It whispered its distress for years, through sagging floors, through damp patches. The maintainers were the city's physicians, trained to hear those whispers. This work required a deep, localized knowledge. A master carpenter didn't just know wood. He knew the specific oak stands that supplied the city. He understood how beams from the north side of a forest behaved differently. He could look at a warped frame and diagnose it. A foundation issue, a load problem, or just a century of natural movement. This expertise was curated by the guilds, the Carpenters' Guild, the Masons' Guild, the Tilers' Guild. They weren't just trade unions, they were repositories of practical science. They trained apprentices through years of hands-on work, passing down techniques. How to scarf a new piece of timber into an old beam, how to repoint stonework so it shed water properly. The guild ensured quality, but more importantly, it ensured the knowledge outlived any single craftsman. It made maintenance a sustainable tradition. The financial model for this upkeep was woven into the social fabric. For grand public structures, the city walls, the conduits, the bridge, upkeep was a civic duty. Taxes were levied specifically for repairs, a shared investment in collective security. For private homes, the responsibility fell to the owner, but it was enforced by community pressure and often by law. A leaning, unstable house threatened not just its inhabitants, but the entire row of homes sharing its walls. A neighbor could petition the city council to force repairs. Your private neglect had public consequences that created a powerful incentive to maintain your vertical property. We can see this regime in the records. Account books from cathedrals show line items, thousands of roof tiles, loads of lime, the daily wages of repair crews. These were not extraordinary expenses. They were the expected cost of existence. The medieval mindset understood that stone was not eternal, and wood was certainly not. They built with the knowledge that their work would demand care. The pinnacle of their ambition, the soaring spire, was always accompanied by a quiet, budgeted line for the steeplejack who would one day climb it to check its stones. This transforms our view of the vertical city. It wasn't a static monument captured in a painting. It was a dynamic process, a continuous negotiation between human creation and natural entropy. The glorious skyline wasn't the result of a single burst of genius. It was the result of that genius being followed, day after day, year after year, by the humble work of preservation. The final, ongoing secret wasn't a clever joint or a legal right. It was the social commitment to upkeep, the unglamorous, relentless labor that prevented the whole towering dream from slowly sinking back into the ground. The power wasn't in anyone's secret being clever. It was how they talked to each other, a feedback loop. Take the timber frame, that flexible wooden skeleton. That was the physical permission. Without that kind of forgiving structure, you couldn't build a jetty, couldn't push a room out over the street. But that jetty, stealing public air, only worked because of the legal idea. Air writes, that framework gave a builder the confidence to make that claim. He knew his overhang was legally secure, an extension of his property column. So law enabled the architecture, but then that ambitious house had to actually be built. The materials came on a hidden highway, the supply chain. Oak from a managed forest floated down a river. Stone from a quarry cut by masons who knew the stress points in a tall wall. That logistical network fed the physical growth, and once that tall, wooden house stood in a crowded row, it became a collective danger. So the community made fire codes, rules about roof tiles, plaster coatings. These weren't arbitrary. They were a direct social response to the danger created by the very density that timber frames and jetties made possible. One secret created a problem, and another secret had to solve it. You see this interdependence everywhere. The need for a defensive wall created absolute land scarcity. That scarcity made narrow plots incredibly valuable. The commercial drive of merchants then demanded ways to maximize profit on those expensive plots. So they built upward and outward, using the technical innovations, the Gothic vault, the flying buttress, to achieve new heights with stone. Those soaring Guildhalls generated tax wealth. And that tax wealth funded the public water conduits below, which made that dense vertical living sanitary, which allowed the population to grow further, increasing the scarcity and starting the cycle again. It was a complex system, like a spider's web. Tug one strand and the tension vibrates through the whole network. A change in property law altered construction. A new fireproofing material allowed for tighter building. A collapse in a trade like saffron in San Gimignano could freeze a skyline in time. The system wasn't planned from the top down. It emerged from countless decisions by carpenters, merchants, lawyers, masons, all responding to the core pressures: defense, commerce, survival within a fixed space. This view changes things. The medieval vertical city wasn't a haphazard pile of tricks. It was a coherent ecosystem. Each secret, the structural, the legal, the logistical, the social, was a strand in a single rope. A rope the whole community pulled on, generation after generation, to haul their city toward the sky. The ultimate secret was the web of connections itself. How human ingenuity, faced with impossible limits, doesn't just find one answer. It weaves an entire world of solutions where every solution supports the next. A medieval mason wouldn't know a zoning code, but his ideas are coming back now on modern drawing boards. First, mixing uses in a vertical stack. In a medieval street, the ground floor was a workshop or a shop. The family lived right above it, then storage or maybe rented rooms higher up. That wasn't just efficient. It made the street alive day and night. The shopkeeper cared about the safety and the cleanliness around him because he lived there. That mixed-use model is a direct ancestor of the modern idea of the 15-minute city. The goal is the same: to have a neighborhood where daily needs, work, food, home, community, are all within a short walk or a short climb. The medieval city did that not by planning for it, but because it had to. Every narrow plot was its own vertical village. That human scale density created interdependence. You knew your butcher, your baker, your carpenter, because they lived in the rooms over their trade. Now, modern planners are trying to design for that same organic closeness on purpose. They see that stacking functions cuts down commute times, it strengthens local economies, and it builds social fabric. It turns anonymous density into a community. Then there's resilience through local supply. A medieval city's timber and stone usually came from the surrounding region. That wasn't just about cost, it was about security and adaptability. Builders knew the properties of the local oak. Masons understood the local limestone. When repairs were needed, the materials and the knowledge were close at hand. That created a circular economy. Wealth from the city funded the managed forests and quarries nearby, which then supplied the city's own growth. Today, we talk about the carbon cost of shipping construction materials across oceans. The medieval model suggests a different logic. A resilient city is partly built from its own bioregion. It supports local industries and it builds a deep, practical knowledge of local materials. This isn't about rejecting global trade. It's about building a foundation of local capacity that can weather bigger storms. It's a lesson in sustainability written in regional stone and wood. Maybe the most poignant echo is the integration of nature into the dense core. The medieval city didn't have grand parks, but it had walled gardens, rooftop herbs, dovecotes. It had water fountains that were civic monuments and lifelines. They understood that even the most vertical life needed a connection to growing things and to clean water. Today's green roofs and vertical gardens are a high-tech return to that same instinct. The medieval conduit system, a gravity-fed network for public water, is a direct parallel to modern sustainable urban drainage. The goal is identical: manage a vital resource within the dense urban fabric to make the city livable and resilient against drought or flood. They didn't see infrastructure and nature as separate. The fountain was both engineering and art. The garden wall was both a boundary and an orchard. Modern biophilic design tries to heal that same split, to weave natural processes back into our towers and streets. The ultimate takeaway for a planner today isn't a specific blueprint, it's a mindset. The medieval city worked because it approached density as a system. Legal, social, material, and ecological systems all had to work together. You couldn't just build tall without managing water, waste, fire, and light. Their solutions were often messy, emergent, deeply pragmatic. We have powerful technologies and complex models now, but we're grappling with the same core challenge they mastered. How do you create a city that's dense enough to be vibrant and sustainable, yet human enough to be healthy and just? The answer, then as now, is to see the city not as a collection of buildings, but as a living, interconnected organism. Every decision about height is also a decision about light, about flow, about community. The quiet genius of the medieval street is that it understood this truth in its bones and built a world to match. Their skyline, it showed something that constraints don't stifle creativity, they define it. This city, bound by its walls, didn't just accept that, it found a new way to breathe. And that was upward, and when you look at their systems, the timber frames, the legal air rights, the water that flowed down by gravity, you see it wasn't a series of accidents. It was a kind of intelligence, a system. Every secret was an answer to a pressure: too many people, not enough land, the need for security. They didn't have our materials. They didn't have our machines, but they had ingenuity, a collaborative kind. The carpenter's joint solved the mason's problem. The merchant's wealth paid for the public water that made the tall house livable. It was an ecosystem, each part supporting the next. What they built, it was more than tall buildings. It was a model for community, where your private ambition to build tall was balanced by your duty to maintain a shared wall, where your right to light was protected against your neighbor's right to expand. That balance between the individual and the collective encoded in stone, in law, in custom. That's the legacy. Our cities now, with steel frames and zoning boards and air rights, we're still doing that same dance. We're using a different language. But it's the same conversation, the one they started, about sharing space, sharing light, sharing opportunity when we live this close. So next time you're on a narrow street, or you look up at a glass tower, see the connection, see that thread of human problem solving. From the oak forests then to the steel mills now, the greatest secret of the vertical city, it wasn't a hidden beam. It wasn't a forgotten law, it was a mindset, a recognition that our biggest challenges, faced with collective will and cleverness, can become the foundation. For our most beautiful things, for what endures, their story, it tells us to look deeper, past the facades, past the spires, to the humble infrastructure. The one that makes elevation possible, because in those hidden systems, that's the blueprint. for a civilization that reached